Another application of matrices is with Leontif technology matrices. And he was a Russian who did work on economics, input-output models, and so these are used a lot. So let's just start by looking at this input-output type thing. This is an output model. Here's my inputs. This is my outputs. Let's see what this really means. So how many units of agricultural products and, well, that just doesn't look good, and of fuels? Oh, of fuels are required to produce 100 units of manufactured goods. So to produce one manufactured good, we need 0.1 units of agriculture and 0.3 units of fuel. So 100 units of manufactured product, I would need 100 times that, so that would give me 10 units of agricultural products, and 100 times that would be 30 units of fuels. Production of which commodity is least dependent on the other two? So if we look down, so to produce agricultural products, we need 0.3 of the other ones. 0.5 of it is from agricultural products. Manufactured goods require 0.5 of manufactured goods, but 0.4 of the other products. Fuels, it's 0.4 fuel and 0.4 of the other, so it's actually agricultural products are least dependent. On the other two. If fuel costs rise, which two industries will be most affected? So which two outputs require most on the fuel? Well, let's look across on the fuel. So the use of fuels is 0.1 there, 0.3 here, and 0.4 there. So manufacturing and fuel industry. Manufacturing and fuel industries are most affected by fuel costs. So each industry has a gross production. The gross production matrix for the economy can be represented by a column matrix, where, like, for example, using that one, X1 would be the gross production of agriculture, X2 would be the gross production of manufactured products, X3 would be gross production of fuels. The amount of gross productions used within the economy by the various industries are given by A times X. So if we took this and turned it into a matrix A, which we should have done up here, so this could be written as A, 0.5, 0.1, 0.1, 0.2, 0.5. I never give myself enough room, 0.3, and 0.4. So we would take that matrix times our gross production, and get the amount of gross production within the whole economy for all the various industries. Those units of gross production not used by the industries are called final demands or surpluses. And so that would be found by taking, so the surpluses would be D. So if I had my gross production minus what was used, I'd have my surplus. And I could kind of factor out the X. And in matrices, the identity matrix is kind of like a 1. So 1 minus A, and here's my production, would give me my surplus. And this is called the open Leontif model. So let's take that first one that we had looked at, and let's take, and we're going to solve that equation. We're going to take I minus A, and then X times X is going to equal my final demands, or my surpluses. And let's say we want to have, hold on. Actually, I wrote it down on, I wrote it as example 2. It's really example 1 because, well, okay. So here's the surpluses we want to get. I just wrote it on the wrong page. I could have done this on the other page. So I minus A times X is going to give me my surplus. Okay, so I is this 111000000, and we're going to subtract matrix A, and whatever we get there would be times our variable matrix, x1, x2, x3 equals the demand. And they give us our demand here that we're going to have, we want to have a surplus of 85 units of agriculture, 65 of manufactured, and we want no surplus of fuel. So let's go ahead and do this part in the calculator. So let me go to matrix A and change that to be what we have here, which is a 3 by 3. That's 0.5, 0.1, 0.1, 0.2, 0.5, 0.3, 1.3, 0.4. And I wanted to see something. We don't have it in there. And so I'm going to change, and just so we see it better, I'm going to make I, my identity, 3, so we can see it. 1, and I can arrow down and just put 1, 1, 1. Okay, so I'm going to take what I call matrix I minus matrix A, and I get this new matrix over here. Well, it would have been pretty easy to do, by hand. I don't know why I did it in the calculator. 1 minus 0.4 would be, yeah. And so we have a couple of things we could do to solve this equation. We could bring this column over, augment it with the other one, and do a reduced row echelon. Or, since I just did this, I'm going to put this in as B, okay? So follow me here. In the matrix, I'm going to change B to be a 3 by 1. And I'm going to take this last answer and I'm going to find its inverse times matrix B. And this is telling me that based on this input-output for production, how much I need to produce to have the required surplus. So it's telling me I need 300 agricultural products. I need 400 manufactured goods. And I need 250 fuels. And that's how we can use this matrix to solve the Leontif situations.